We have seen the previous concept of 3D printing, and now let's talk about another fascinating and futuristic technology known as edge computing. Imagine a busy warehouse with hundreds of sensors monitoring inventory levels, conveyor belts, temperature, and equipment health in real time. Traditionally, all this data would be sent to a central cloud server for processing, but delays in communication could affect decision-making. This is where edge computing comes in, enabling real-time processing and faster decisions right at the source. Companies like DHL and FedEx are exploring edge computing to optimize last-mile deliveries and warehouse automation, improving operational efficiency significantly. Edge computing is a technology that processes data close to where it is generated, instead of sending it far away to a central cloud computer. Imagine a security camera in a warehouse. Instead of sending hours of video to a cloud server to check for intruders, the camera's local system quickly analyzes the footage on site and raises an alert immediately. Another example is in a smart factory. Sensors on machines monitor temperature or vibrations. Edge computing processes this data right there on the factory floor, allowing instant decisions like stopping a machine if it's overheating instead of waiting for cloud analysis. So, edge computing makes systems faster, reduces internet traffic, and helps businesses act immediately on real-time data. While the concept started gaining traction in the early 2010s, it has become increasingly relevant due to the rise of IoT devices and real-time analytics needs. To understand how it works, let's take a simple example. Suppose a warehouse uses sensors to monitor the temperature of perishable goods. With edge computing, these sensors can process data locally and immediately trigger alerts if temperatures exceed safe limits, rather than waiting for cloud-based analysis. This enables instant corrective actions, such as adjusting refrigeration or rerouting shipments, minimizing losses and maintaining quality. Now we will talk about the uses of edge computing. Our first type is real-time monitoring. By processing data locally, businesses can detect anomalies in equipment, temperature, or inventory levels instantly, reducing downtime and wastage. Our next type is predictive maintenance, where edge devices analyze machinery data on site to predict failures before they occur, saving costs and avoiding operational disruptions. Another key use is enhanced supply chain visibility. For example, logistics companies can track vehicles, monitor traffic conditions, and optimize delivery routes dynamically using edge computing, ensuring timely and cost-effective deliveries. A top real case study is Maersk, the global shipping giant. Previously, Maersk faced challenges in monitoring container conditions and tracking shipments in real time across remote locations. Around 2020, they implemented edge computing solutions with IoT sensors on containers and vessels. By processing data locally on edge devices and sending only relevant insights to the cloud, Maersk improved container monitoring, reduced shipping delays, and enhanced supply chain visibility. The company reported faster decision-making, fewer cargo damages, and significant cost savings in operational logistics. So we've simply seen how edge computing brings processing power closer to the source, enabling faster, smarter, and more efficient operations. In a nutshell, it reduces delays, improves real-time decision-making, and strengthens supply chain resilience. Hopefully, you found this concept very insightful. Now, a very important topic we discussed, and that's amazing learning I believe you have today.